So far this week, we've looked at the way in which you can explain one variable using another. We've seen that we can relate win percentage to Pythagorean expectation and show that there's a close fit between these two variables. But so now we're going to go one step further and ask whether we could actually forecast win percentage in the future using historical Pythagorean expectation. And of course, that's one thing we're interested in with data analytics. You can think of it there being two aspects to this. One is, can we explain what's happened in the past? And the second is, can we forecast what's going to happen in the future? So let's see how we might do this with baseball data. And what we're going to do is we're going to divide a particular season into two halves. And then we're going to take the Pythagorean expectation from one half, the first half of the season, and then we're going to see how well that fits with the win percentage in the second half of the season. And as a control for that, we can look at how well the win percentage from the first half of the season fits with the win percentage of the second half of the season. And if our Pythagorean expectation did better than win percentage, then we might think that that's not a bad forecasting tool that we might have at our disposal. So let's go about it and see what we find. So we're going to start off in the same way before. We're going to import our packages, import our data, take a quick look at the data, see what we got. Again, we're familiar with this, so we've actually seen this before. And then we're going to go through the same process we've done. We did this right at the beginning of the week, but we've done this for all the other sports as well. We're going to create the summary data for win percentage and Pythagorean expectation for each team as home team and as visiting team. And then we're going to combine those two data frames together. Now we're going to do something different now from what we did in the previous notebooks. We're going to use the command concatenate, concat, pd.concat, which is instead going to stack the two performances of the teams on top of each other. So rather than merging them so you've got the home performance data on the left and the away performance on the right, we're going to put one on top of the other. So you've got home on the top and away team performance on the bottom, so that we've got a list essentially of all games played across the season. So when we do that, you can see that we have a list that is now 4,862 rows long. So effectively, we could then now list this in date order, so because we've got the date of this in the data frame, and then we could create a subset which was going to be performance up to a certain point in the season. And that's how we're going to create the two halves of our data. We're going to look at performance in the first half, which I'm going to choose an arbitrary date for, and then look at the second half. So we still need to define what is a win in this data. So again, a win is obviously where you score more runs than the opposing team. So we run that first. So we've got now wins in our data. So I'm going to divide the data according to the All-Star game. So that's usually taken as the midpoint of the season in baseball. And in 2018, the All-Star game was on July 17th. So the code for that in the data using our date is 20180717. And then I'm going to use a command we haven't seen yet, .describe, to show you what that data looks like. So .describe shows you, if you look across the top, it gives you the count. So how many observations do we have? So there were 2,886 games up to the All-Star game in the season, and it gives you some other statistics, descriptive statistics there that you might want. And then we can do the same thing for the second half. So I'm going to create a subset out of the data called half two and describe that. So we've now two halves of the data, half one, the results for the teams in the first half of the season, and half two, the results for the teams in the second half of the season. So now I need to create the performance variables for each team in each half of the season. So I'm going to do a group by again. And so the group by looks very similar to the sort of group by we've been running before, but because the data is stacked, we've already taken account of when the team's a home team and when the team's an away team. And you can see here we've got the performance for the number of games played in the first half of the season for each team. Again, we've got 30 rows of data, number of games played, number of wins, runs for and runs against. And so we can now create our performance statistics for the win percentage and the Pythagorean expectation for the first half of the season. And again, so we've just created those numbers here in the way that we've done it at every stage before. And likewise, we're going to create the performance variables for the second half of the season. So we're going to call this half 2, and that's going to be again a dot group by, where we sum again these variables, the same variables, games played, the count, wins, runs scored, and runs against for the second half of the season. And we can create from that for the second half of the season the win percentage and Pythagorean expectation for each team. And since we've now got, for all 30 teams, their first half of the season and their second half of the season performance, let's merge these two data frames together, which we're going to, so I'm calling this half 2 predictor, because I'm going to use the data from the first half to see how well it predicts performance in the second half. So here we have the 30 rows of data, one for each team, and their performance statistics for the first half and for the second half of the season. So let's just run a rel plot then. So let's run a rel plot where we have our x is the Pythagorean expectation from the first half of the season, and our y is the win percentage in the second half of the season. So let's see how closely these two things look together on the same chart. Well, there you've got a scatter, right? So it's not quite as perfect as we saw when we looked at the simultaneous Pythagorean expectation and win percentages, but it's not like the cricket where there's no relationship at all. There's clearly some kind of relationship there in the data that we can see. And just to see how reliable that might be, let's compare it with the win percentage from the first half of the season using the win percentage of the second half of the season. So what does that look like when we do? And you can see here it's actually rather similar. So perhaps that's not surprising because win percentage and Pythagorean expectation go closely together. It's perhaps not surprising that we see predictor of win percentage in the second half of the season as roughly similar to the Pythagorean expectation. So now what we're going to do is look at correlations to see which is more correlated with performance in the second half of the season, win percentage in the second half of the season. Is it the win percentage from the first half of the season or the win percentage from the second half of the season? I'm going to create these variables here and create the correlation. So what I've done here is I've defined a set of variables called key vars, my key variables, and then I'm asking for a correlation matrix for our key vars. So that's what this looks like. So let's read this across the top. So here is the variable we're particularly interested in, win percentage in the second half of the season. And here is the level of correlation between win percentage in the second half of the season and our other variables. Well, what are our other variables? So the first is win percentage in the second half of the season. Well, of course, it's perfectly correlated with itself, so that's just has a value of 1. That's going to be true across the diagonals in this matrix, so you can just ignore those. But here's the thing we're interested in, the correlation between win percentage in the second half of the season and win percentage in the first half of the season, and the correlation between win percentage in the second half of the season and the Pythagorean expectation in the first half of the season. So the first value here is 0.652 and the second value here is 0.691. What that means is there's a closer correlation between the Pythagorean expectation in the first half of the season and win percentage in the second half of the season than there is between win percentage in the first half of the season and win percentage in the second half of the season. So that in telling us that the Pythagorean expectation is actually working better than win percentage. And this correlation coefficient is relatively high. So that means that in some sense we would do well to use Pythagorean expectation as our forecasting value for win percentage rather than win percentage itself. And that Pythagorean expectation is going to be a fairly good forecaster of win percentage. And in fact, it's worth pointing out, this is precisely why Bill James originally advanced Pythagorean expectation as a useful measure in baseball, precisely because he thought it would be more reliable than looking at win percentage. So what we've shown with our analysis of the data here is that Bill James was exactly right, which is perhaps not a surprise. It is a very nice illustration of his insight about the value of Pythagorean expectation. And one thing we can see here is if we just do a sort to see how close the relationship is for each team. So we've sorted here the values by win percentage in the second half of the season, and you can see here what that relationship is. And indeed, as you go down, you can see which ones are highly correlated and which ones are less well correlated. And so that's something, if you're interested in looking at individual teams, that you might want to study. So to conclude what we've gone through this week, we've looked at a relationship between variables in sports. We've looked at the relationship between win percentage and Pythagorean expectation and explored how closely these two things go together. What we found is that generally in most sports they do fit very closely together, so they are highly correlated with each other, although we found that cricket was an exception. We've also found that not only can you use a value like Pythagorean expectation to understand or explain the relationship of data in the past, but you can actually use it as a forecasting variable. And that's something that we're going to be interested in as we progress through these MOOCs. So that gives you the idea and a sense of the power that there is in using a framework like Python to analyze sports data. We're going to obviously go through these techniques in much more detail and make you much more familiar with how to use these things yourselves, and hopefully that's going to become clearer as you progress through these MOOCs.